assignment I've ever had to do here in Finley was I had to make a YouTube
Video. Yeah, somebody made you do that. That was me. Remember your safety law? Yeah, I knew you.
The worst assignment.
That was me. I'm not going to make you do a YouTube video in here, okay? That was a safety law. Okay, guys, we're going again. Let's go through some quick information on toxicology. This is the presentation I did post. I did 2 on toxicology. Basically a broad field. You guys know that. You can study basically with tox. You can do molecular basis. We can look at several areas. It's truly Sherlock Holmes. You got to use all your sciences to do that. So we talked a little bit about mechanisms of actions, how it affects you from adverse into where you see those exposures. And I like this one because it talks about observable steps. So talked a little bit about break. We were talking about medical. So if you notice, here's your home, here's the doctor, the key event, mode of action, here's the event, store, and then your library. You can kind of see your mode of action there. Real important, epidemiological studies, your laboratory studies, or your animal studies. You need to understand which of those you're looking at when you're doing toxicity data. They will change. Here is biomarkers, some things you may see as you're looking at it. And what I like to do is body weight, changes in weight before and after. Also, some of the lower, or what I'll call neurological behavior, changes in appetite, aggressive, lethargy, things like that you may see too. So the weight of the evidence is, again, the strength, consistency, how specific they are, and the last one, most important, Paracelsus would be happy, it's dose that makes the poison lethal, so the dose response. And your toxiokinetics, again, here's what I want you guys to remember, the ADME, absorption, distribution, metabolic rate or metabolism, and elimination. Any questions on this one? You guys happy with the rate? Any place I missed here? This is the only exposures? Usually somebody will argue with me, or good argue, and say, hey, you're missing one. And I always think, no, it's pretty good. I changed it around on you a little bit. Notice I did the percutaneous. Basically, that is the injection. I had to use a different word on this one. Here's your biggest thing I want you guys to know about particle size. Very important. Particle size, respiratory tract. So why when you go into a dusty environment, do you suddenly not worry as much about it going all the way down in your lungs? If it's a very dusty, like somebody's cutting wood, do you worry about that dust going into your lungs? Where will it stay? Usually you'll taste it right in the upper. So the reason is greater than 5 microns, again, how it exits, we wipe it, we blow it, we sneeze. That's why we have that reaction. The body's a wonderful thing. 2 to 5, basically it may get coughed out, it's swallowed. Less than 1, it's typically going to be in the bloodstream. I had somebody today do a presentation on Chrome 6. Obviously, they were welding on it. That's where they got into the lungs, and it did create a problem. My favorite one, adsorption, absorption. What's the difference, guys? So AB, sorption, and AD, ad and ab. How would you explain it to a 10-year-old?
Absorption of something is something that they become
Okay. So, depending on the properties of the chemical, absorption, like it's absorbed. What about this? What's adsorption? What are you doing? AD. Yeah, it's on the surface. So, here's your thing. In industrial hygiene sampling, charcoal, media, you're absorption. If you're doing a liquid bubbler impinger, you've got liquid absorption. So again, if you need to look at that, that'll kind of be discussed in some of your reading. Again, rate of absorption, and you'll notice time to reach peak concentrations after exposure. Your bioavailability, again, it's how much is left behind in the body. So let me ask you guys this, air sampling, does it represent how much your body takes in? If I've got a pump and you're sampling here and you're exposed to something, does that represent your body burden or how much you took in? Yeah, it doesn't. It may be representative, but it doesn't represent. And again, distribution, how it spreads through the body. And this is important for you guys to understand. How do we get rid of toxic materials? Yeah, excrete it. What's that valuable to you as an IH? If you understand how the chemical goes in, inhalation, absorption, all those, then and you understand what goes out, you can do air sampling, then actually see what's discharged, and you can actually do that body burden you'll hear me talk about. The half-life, how long it takes is common sense for half of it to go away, and here's my favorite one. So dose response curve, where do you want to be on this? If you guys look, the threshold dose. So I want to be there or below, right? Why would I want to do that? So that threshold dose is where I'm going to start getting a reaction. Where do I want to keep the exposure, which is around 10? Where do I actually run it? Yeah, 0. Why do I want it at 0? Or where there's no observable adverse effect. The NOEL, and you guys will see that here in a second. So, here were some compounds that they said basically, again, rats. I can't get away from that, Dave. You've now got me, I'm going to start a petition for rats. I can see it now. Protect the rats.
He already has one.
I know. I doubt it. I don't know. So, here's the thing. One of the things with the liver toxicity, basically metabolic rates as you're going through that, one of the most common sites is the liver. The liver's kind of the cleaning out. A lot of toxins, when you read it, you're going to hear that the liver's the target. The reason is, again, that is like your cleaning system for your body. And the kidneys also, and you'll hear that too. And again, kind of ahead of myself, it regulates all the electrolytic balances and pH. And again, I tried to give you guys kind of a look of what the kidneys look like. Lungs, we've already talked about it. Size of the particles, unless it's a gas, and what happens there. Again, on the other chart I gave you, it was kind of handwritten. Here's your TLV, which is not threshold limit value, but total lung volume, vital capacity, and total volume. And again, that is normally what is done on a spirometer, or basically when you test their lung function. Health effects, you guys know that, edema, fibrosis, some of the emphysema. We know that's how you affect the lungs. And then I tried to give you guys on this chart kind of a graphic of how oxygen, carbon dioxide's exchanged and where that gas exchange goes. And if you notice, you've got capillary flow, you've got oxygen in and out, and you've got carbon dioxide going out. And neurotoxicity, basically different body functions. And again, the signals there, the pathology will determine that. And you guys can see different sheaths and some of the centers. So just kind of gave you guys that. Here's the big one, reproductive hazards. Only one gender or both genders?
Both genders.
How's it both genders? Women only have babies. Why do you think it's men?
Stuff can affect this one.
There you go. It affects both sexes. There for a long time, we used to only think about female reproductive hazards. Now there's a lot of work on that. And again, if you even look at the slide, you know, it talks about impacts to the embryo, fetus. That's why we're looking at that. Immune toxicity, basically, if you think about it, the body's designed, a lot of chemicals, the body will protect itself, and that's what sometimes happens there. And then skin toxicity, again, your ACGIH booklet will kind of list toxic chemicals there. I tried to give you guys some carcinogenesis and genotoxicity, give a couple of definitions there just so you could refer to that. And that's kind of the slide for the toxicity. Any questions on that?